So we're going to start. Our first talk in this session will be by the dreameRs team, Victor, Fanny, and Étienne.
Hello everybody, and thanks again to the organizer. I'm Fanny and I work at dreameRs. dreameRs is a small data science consulting specialized in R. We founded it with Victor almost 2 years ago. First, I hope you will be able to understand me because I'm stressed and my English is very, very bad. And expect for ordering for a beer. I don't have much practice English, forgive me. To get back to the main topic, we will introduce you a proof of concept of a Shiny application. The main goal of this application is to find the most suitable job description for a person. We have developed this POC for l'INSEE, the National Statistic Bureau of France. And special thanks to Arnaud Degore, who trusted us. Before I show you a first demonstration of the app, I will introduce you the background and consideration behind the app. Then Étienne will explain you the text mining and algorithm part, and finally Victor will show you the underside of the Shiny application, module, database. First, we start to work with INSEE because the Minister of Economy and Finance has set up a managerial program. The first item of this program is to better know the executive manager, their skill and their career aspiration. The second part is to better follow up a longer career and their mobility. The third item is to help identify executives who might be able to be promoted, and finally better coordinate a good match between supply and demand, and for that develop tools to help in recruitment. The human resource department of INSEE, as well as all departments of the ministry, have set up an experimentation to find answer to this program. For this, there are 3 main data sources could be useful. Data for human resource information system. It tracks all the statutes of administrative act. Then job description and resume. And finally, career interview data. It's the note of the manager during the interview. The prototype developed in INSEE was a Shiny application. The main feature is to search keyword inside resume and job description, visualize agent progress, a notebook to note all the career management, and the POC Tinder. POC Tinder, INSEE asked us to develop this new feature for a process to help executives to find a new position. We called POC Tinder as reminder of the dating app. You only need to swipe to the right or to the left to find love. Finally, it's a little bit more complicated to find a job. After a brainstorming, we determined the main context of the POC. We was different sources of job description. We have limited ourselves to the most formatted ones, which represent 450 job description. We also had a lot of discussion about what to use an internal data, and we've decided to make prototype in a blind mode without using past or current position. We keep that for maybe a future evolution. The main goal, as we say before, was to have a fun and quick application for user. We don't want to lose user before the end because the process is boring or too long. In terms of concrete final output, our application must provide 6 job descriptions to user and allow them to download this description as PDF. To do that, we have defined 2 main steps. The first step was to conceive an app with an appealing design while respecting the identity of the application in which this one will be integrated. How can we present the job description without being boring, for example? The other crucial step was to determine a text mining model to do the job matching behind the app. And the final step was to make both work together, which gave the application I will show you now. So the application are split in 2 tabs. This one is only for the admin of the application. This part is to see all the job description. We can click to see the job description and edit tag. I explain you later what is a tag. And we can add a new job description. There are 2 edition tags. The app work with topic or clusters, and each cluster are represented here. We can show all the cluster, show all the term to contribute to the topic, and all the job description. And we can also rename the topic because by default it is a free first term. Then the game or the process. There are in 4 parts. The first one, we have all the topic, and we have to decide if it interests me. For example, études et synthèse économique, ça m'intéresse, but R&D education, I don't care. And gestion de projet, it's interesting not. Then and the second part is 2 job description, and we can visualize with a workflow or all the description. The 2. Oops. And we have to choose which one you prefer. For example, I prefer the fish one, chef de section administrative, direction des sirènes. It's 5 times. I have to choose 5 times. Up, I prefer the 2, the first again, and the first again. And then the 3 part is to validate the preference of the agent, and we saw 5 job description, and we have to say if yes, this one I like, I love it, but this one not, and this one bof, moyen. Je sais pas comment descendre. Ça marche pas. I validate. And finally, we have 6 post description. We can visualize them, or we can download. Voilà. And we have also all the post description we have loved before in the process, because maybe there are interest too.
Thank you. Okay, so now that the demo is over, we are going to have a closer look at what happens behind the scenes. And I'm going to talk about the text mining part, and after that, Victor will talk about the shiny part. So I'll begin with explaining the first step we did. It was about text processing and creating clusters. And after that, I'll explain how we succeeded in integrating the users with the result of clustering. So this is the first step. Thank you. It's a fairly common step in all text mining projects. It's kind of unavoidable. You have to pre-process the text data to obtain useful and clean things with which you can work. So I'm going to go briefly into these details. So first, we started from 450 job descriptions. So that were just raw PDF files. So at first, we had to apply a few regular expressions to parse the information inside them. And then that's fairly classic, we tokenize the sentences into words. Then we stemmed those words. So for those of you that are not familiar with text mining, stemming is just about keeping the main part of the word. That is to say, like if there are little like useless things at the end of the word, like ed or something like that, we just keep the main part of the word. So studied would become study. We removed all the stop words. The stop words are the little words like an, the, if, in, and so on. We used n-grams. So n-grams are groups of consecutive words. For example, 4 grams are all groups of 4 consecutive words. And actually, we did that because it's very well known that using n-grams allows to capture more meaning from the text data. And we removed all infrequent words and also the words that were very frequent in all the documents, because since those words appear in almost all the documents, or almost none of them, they don't convey any useful information for the modeling part that will come next. And last step, we applied the TF-IDF. I don't know if you know that. It stands for like term frequency, inverse document frequency. And that's also a very common algorithm. Like it just aims at giving more importance to certain terms and less importance to other terms according to their frequency of operation in the corpus and in the documents. So these different steps allowed us to obtain the matrix that you can see on the right part of the slide. So it's just a matrix with the lines are the n job descriptions, and the columns are all the terms. The term being the n-grams we obtained, and this matrix is filled with numerical coefficients. And let me just mention the packages we used for these tasks. The first one was text-to-vec. It's a very useful and efficient text mining package by Dimitri Selifanov. And we also used Stringy and data table. So now, starting with this matrix, we used algorithms like we experimented with k-means and LDR, which is a latent direct allocation, to work on this matrix, because what we wanted to obtain was clusters. And so these are two classical algorithms that allowed us to obtain clusters. Finally, we kept the LDA. And well, I won't go into the details of LDA. If you want to know more about it, you can just Google it. But what you have to remember is just well, we just feed our input matrix to the LDA, and we obtain another matrix with the term in columns and k clusters in the term in lines and k cluster in columns, and these clusters are going to be very useful. Thank you. So with the two matrices we had, we just combined them. Actually, it's just a multiplication to obtain a third and last matrix. And this matrix on the right is the important one, and we are going to use it again for all the remaining part. It consists of n job descriptions in the lines, and the k clusters are in the columns. And so, in fact, each coefficient gives the importance of the cluster in the document. So I'll try to be more clear. Like if you take just the first line represents the first document, so the first job descriptions. So it represents just the first PDF that we have, and like the first coefficient is the weight of this document on the first cluster. So, for instance, say the first cluster is about knowledge in economics, and the second one is about statistical skills. But then if you have like a 0.9 as the first coefficient and 0.1 at the second, it means that this job is a lot about economics, and you don't need to need a lot of statistics to have this job. Okay, so now what do we do with this matrix? Because this matrix allows to represent all the documents, but now we have the user, and we want the user to interact with the documents. So that was a more challenging part, because all the previous steps were quite classical, but now we had to like kind of invent something new to make the user evolve into the job descriptions. So what we did is we just, thanks to a matrix, we can consider that all the job descriptions are inside a big space, a k-dimensional space, and each job description is just a point in the space, and so the axes of the space are the k clusters, and so the user is just one point in this space. So we consider that a user has the same structure as a job description, so it's just a list of k coefficients. So what do we do now? So these are the 4 modules that you saw in the demo. So the first one was about selecting some tags you liked or didn't like. The second one was about making choices inside pairs of job descriptions. The first one was about writing job descriptions, and the fourth one was just giving the results. So right at the beginning, the user is at the center of the space. After that, what happened? As you can see, the user moved. So how did he move? For this first step, it's fairly simple. We just, like you see, the first coefficient is 0.5, so it's because he selected the first tag, which is the same as a topic. which is the same also as a cluster. And he selected the first topic as in the I like it box. And the second coefficient is minus 0.5 because he selected this topic in the I don't like it box. So that's a simple first step into the space. And after that, what's going to happen? We're going to limit ourselves to a tinier subspace. So we keep only the 100 job descriptions that are the closest to the user. And among these 100 job descriptions, we randomly pick 10 of them. So 10 of them are 5 pairs of jobs, and we use them in the second modules. So now the user is at the beginning of the second module. Remember that module was about choosing between two jobs 5 times. And so he does five choices, and what happens? So as you can see, he moved again. And actually, how does he move this time? This time it's a bit more complicated. In fact, each time he makes a choice between two job descriptions, we'll recompute his position using a kind of weighted mean. So I won't go into the details, but we just carefully selected coefficients of this weighted mean, so that the user gets a little closer to the job it chose, and without getting too far from his previous position, and at the same time he moves a bit away from the job he didn't choose. And so after the second module, the user has a new position, and after that he goes into the third module, and that's the same principle. Like he writes in the third module, remember, he writes job descriptions, and according to the weight he gave, we compute its position at each step. And after that, we arrive in the fourth modules, and for the fourth modules, it's simple. Actually, if everything went well, the profile of the user has converged to a very tiny area of the space, and so we just keep the final position, the final profile of the user, and we retrieve the 6 closest job descriptions, and like hopefully, if everything works well, those 6 job descriptions are like dream jobs for him. So thank you. Now Victor is going to tell you more about the shiny part of the project.
Thanks, Étienne. So I am Victor. I will enter the detail of the application we have developed for this POC and tell you about these main features. Donc, we have made intensive use of Shiny modules. Donc, I will present them how we have worked with them. The final application is integrated in R package, so we'll discuss about the main advantage of this development method. The application needs a SQL database to run where job description has been stored, and where admin user can edit them. And finally, we have implemented user tracking functionality to record what the user do with our app. So here's the global architecture of our app. The initial constraint for the development of this application was it had to be able to be included in a global application made by INSEE. So to answer this problem, we have decided to use Shiny modules, which lend themselves perfectly to the net. We created a main module to host our application, which be called by INSEE dev. And the process developed to define the user path is divided into 4 steps, which Fanny introduced you earlier. We have therefore developed each of these steps as a module, and these sub-modules are then called by the global module. And all the calculation Etienne talked about are made in the main module. Pardon. So why use Shiny modules? They exist since version 0.13 of Shiny package, and have been designed to address two main issues. Simplify the reuse of Shiny UI server logic, and make authoring and maintaining complex apps much easier. Modules are functions, one for the interface and one for the server, that communicate with each other through a dedicated namespace. Developing Shiny applications using modules has several advantages. It simplifies the code of application by splitting into a smaller break. Since modules are functions, it's easy to integrate them in a package. Modules can also be used several times in the same application, even it was not the purpose here, but can be reused even in a third-party application. Since the modules are small components, it's easier to read the code, and it's possible to launch a module outside the main application in which you want to integrate it. So how we design our modules. Each module has a UI function and a server function, and some take input to work, and our modules return output value as reactive values. So I will enter in the detail of each modules. So developing these modules was not so complicated. Fanny wrote the design, so I just coded after. There's some complicated stuff. She wanted drag and drop thingy, so we integrated the drag and drop thingy. These modules can take only the main theme, the main topic of the job description to run, and the user select what he like and what he dislike, and those are the results of the modules as the reactive values. Those data are used to draw a job description in our database, and here comes a second module. So once again, in the Fanny made the blueprint of the module. The only complication was flipping card, but we integrated the flipping card. This module takes a reactive function, which returns a table with job description, and as output returns the reactive values with jobs selected or rejected by the user. With that information, we update the text mining algorithm model, and we draw another job description to show to the user. So here comes the third module. And as output, we have the ID of the job description and the score given by the user. And the fourth module, the last one, which don't output anything, but allows the user to see the most suitable description according to this past choice, and allow them to download them as a PDF. So developing modules. Each of the modules, the four modules we saw earlier, each has been developed independently, so each can be run with the other, since all the calculations are made in the global module. And at the end, we just need to connect the dots between them to make the application useful. developing modules allow you to have a smaller R script. So instead of having a big application of thousands of lines of code, we have just script with max 200 lines of code. And since modules are function, it's easy to document them, and it's advised. So, mostly to explicitly specify the input value, what the module need to run. Our modules all takes a reactive function that returns a data frame, and what the output of the modules. Our modules put reactive values with several slots. Here, for example, the slots with a selected and rejected ID of a job description. And since we have a written function and have documented them, it's easy to integrate them in the package. And one of the important steps of integrating modules into a package is the management of the namespace. You can do import Shiny since you use a lot of Shiny function, but it's safer to make the effort of making import from for each function you use. It allows you to know what do you use in Shiny, and if you depend on a specific version, for example, since a function added at each version. Integrated in a package can allow you to efficiently manage your HTML dependencies. For example, the drag and drop thingies, flipping cards are made in JavaScript and are included in the package as function. And we manage our dependencies with the HTML tools package. Some resources about modules. Donc the official documentation, there's always something to discover from the Shiny website. There is a talk of Eric Nance at the last Studio Conf too, which is good, and an article in French by Quentin Fazio. So I will talk the database beyond the application, which is the backend. Our application uses a SQL database to store the data using it. So jobs description have been integrated in a table, and all that remains is to make a query based on the ID to read the data. The app user mode simply reads the data from the SQL database, while the apps admin mode allow to write into the database. And all interaction with the database are performed with functions that manage the connection and disconnection inside it, and completely outside the application, so you can use this function in another context than a Shiny application. That's easier to test, to see what they do. We use a SQLite database for the prototype, for fast iteration and easy manipulation of the data. When the app will be deployed, the objective is to use a PostgreSQL database. Thanks to DBE, we hope we just have the DB Connect step to modify. And the last part we integrated in our application is the tracking mode. The application offers many choices to the user on which our text mining algorithm is based. It was important to know what choices the user has made in the different modules and what the algorithm has answered, in order to validate the convergence of the algorithm and the relevance of the jobs offered. and also to see how many users completed the first steps of the process. To do this, we have a place function recording each of the output for some models into the main models in the second SQL database. To go further, also, the result of the tracking can be cross-referenced with internal human resources data. Our application does not manage authentication of an agent of INSEE, but the one in which it will be integrated offers the user to authenticate himself if he wishes. Unfortunately, you won't be able to play with this application, except if you work at INSEE. But we have other application you can play with in a Shiny gallery we have made at this URL. Voilà. Tu veux présenter dreameRs, Fanny? Okay. Donc, thanks. That was Fanny, Étienne, and Victor.